Right, key assessment 3, higher tier walkthrough. Here we go. Question 1. We need to convert 9.35 pounds into kilograms. And what we do know is we know that 2.2 pounds is equal to 1 kilogram. So if we've got 9.35 pounds, we need to find out what that scale is. So first off, if I look at this and I go, right, well, I need to find out, let's see if that calculator's clear, how many times 2.2 goes into 9.35. So do 9.35 divided by 2.2, and I get an answer of, I can also get a fraction, so press the SD button, and I get 4.25. So that means if I divide this by 4.25, I get 2.25, and of course, round robin, I go the other way around, and that is going to be 1 times what 4.25 is going to give me 4.25. So that is my answer there. Okay. Question 2, we've got temperatures listed in 6 cities in Celsius, and they want the outlier, depending on how you prefer to say it. And if I look at 1 degree, -2 degrees, 1 degree, 1.7 degrees, 18 degrees, and 3 degrees. So no prizes there really, apart from the 1 mark. 18 is our outlier. Now, question 3, all to do with parts of a circle. Okay. Now, I'm going to be moving about on this one just so we can see where we're at. So if we look, the first one, they've already labelled one of them for us. They've labelled C, which is our radius. So then we need to look at the others. Now A, we can see there, it touches the circle but doesn't cross it. So A is a tangent all the way down here. Okay. Then B, when we look at B, B is shaded in and it looks like a piece of pie. So B is our sector. So that's now drawn in. And the last one, D, D crosses the circle one side to the other but doesn't pass through the centre. So D is a chord. And that's what we should end up with there. Okay. Question 4. Now it gives us a few hints here. Tells us it's an equilateral triangle, so we know all 3 sides are equal. And it says the measurements are in centimetres, which they're not at the moment. And we want to work out the value for the perimeter, so all the sides. So what we do know, being an equal sided, we know that this is equal to that. So I can now write that as 5x minus 1 is equal to 3x plus 7. So I'll go through the steps. So I've got an unknown on both sides, so I need to get rid of one or the other. I'll get rid of the smaller one because it's the easiest. So I'm going to take away 3x on both sides. And that will leave me with 2x minus 1 equals 7. And it is a positive 7. So now I've got a 2-step equation. So I'm going to add 1 to both sides, which will leave me with 2x is now equal to 8. And of course, 2 times, so I'm going to divide them both by 2. And that will leave me with x is equal to 4. So far, so good. We can now substitute that in. We could do it on either side. We now know the value of x. So here I've got 5x minus 1. So if I do 5 times 4, take away 1, I get 19. And you've done it there. You don't need to do this, but I'll do it to prove it. If we do 3 times 4 plus 7, we get 19. So that we now know for sure that all sides are 19. And we can now do final one. We can just add the 3 up, or we can do 19 times 3, which is going to give me 57. And that is our answer, 57 centimetres. Okay. On to question 5. And we are dealing with this time a pie chart. Results of matches. We've got 1 lost and drew. And we know that 60 matches were won, so I'll put my 60 in there. And if I add the 1, 3, 2 and the 48, that's 180. So I know 60 is half of my circle. So full circle, is equal to 120 games. Okay. So now I can take my fraction, because we only want how many were drawn. So I can take my 48 degrees out of 360, and then I can times that by how many games were played, 120 there. And let's put that into the calculator exactly as it looks. Let's clear off that previous one. So 48 over 360 times by 120, and look, the same mistake, go back. See how easy it is to do? Remember to move the cursor, times by 120 and equals, and we've got 16 there. See how easy it is to make a mistake if you're flowing through and you think you're doing exactly the right thing. Always double check what you're putting in on the calculator, because what you put in on the screen should mirror what you've got written there. Okay. See, we're human, we make mistakes too. So question 6. We've got a scale diagram showing towns A, B and C on a centimetre grid, and we want the actual distance from B to C. So from B to C. And it's a centimetre grid. So if I line up, I go 1, 2, 3, 4, 5.5. So I've got 5.5 centimetres. And we know the scale is 1 to 300,000. So if I do 5.5 times 300,000, I ain't doing that in my head. So 5.5 times 300,000, and I get an answer of 1,650,000. So far so good, but that is in centimetres, and we need the answer in kilometres down here. Now some of you may be able to go straight from centimetres to kilometres, but I'm going to go the middle point, I'm going to go metres in the middle. So first off, I know there's 100 centimetres in a metre, so I'm going to divide by 100, and then I know that there's 1,000 metres in a kilometre, so then I'm going to divide by 1,000. So same again. I've already got my answer up, so I'm just going to divide that by 100, which gives me 16,500. And I'm going to divide that by 1,000, which gives me 16.5. And that is my answer, 16.5 kilometres. Okay, so we were working with scale. Started off with centimetres, ended up in kilometres, but we still end up with the right answer. But I can't get rid of this just yet, because part B of the question says A is northwest of B, and write down a bearing of A from B. So what they're looking for is the bearing of A from B. And if we, so it's that direction, and if we remember our angles and our bearings, we always measure from north, we always measure clockwise, and it's always in 3 digits. So we know here, and of course it's on a 45-degree line, so if you know your angles, you will know as we come round, east is 90, south is 180, west is 270, we add another 45 degrees on, so we end up with 315 degrees. Now we can get rid of that. Okay. So question 7. We want 3 weeks as a fraction of 9 days. So 3 weeks equals 21 days. So I've got 21 over 9. And then I can simplify that down. We know 3 goes into each, so we end up with 7 over 3. And that's going to be my lowest. And that's all we can do on that one, 7 over 3, which is good. Part B, 72 centimetres equals 2.25 metres as a ratio in the form 1 to n. And they've done an extra thing there. They've got centimetres and metres. So at the moment, I'm going to change that. So if I look at my ratio and I've got 72 centimetres. Now 2.25 metres is 225 metres. And in the ratio of the form 1 to n, that means this must be 1. And whatever that ends up as, it ends up as, okay? So of course, To get 72 down to 1, we're going to divide it by 72. And then of course we're going to do the same on the other side, divide that by 72. So we're going to do 225, move that over so we can see it, divided by, and what do we say, well 72, and we get an answer of 3.125. So that means for every 1 in here we get 3.125 in there, so 3 1/8. And then on to the last one for some fractions. A is a fraction of B, so we do A to B. Now A is 2/5, B is 9/10. So first thing I want to do is get them the bottom numbers the same, so I'll double this to get 4/10 to 9/10, and it says A as a fraction of B, so that will give us 4/9. Now, linear sequences. We want the nth term for this sequence. I'll go through the basics. So we need the sequence, we've got our terms, so we've got first, second, third, fourth and fifth, just for the argument of it for now. We do need that many. The second is 7, so I'll put that in, and the fifth is 22. Now what we've done there, if we look, we've gone 1, 2, 3 spaces, so we've moved up, and if I do 22 take away 7, I'm left with 15, so that's 15 between the 3 steps. So divide that by 3, and that means I'm adding 5 each time, and that will get me to the 22. So that gives me the first part of my sequence, so that will give me 5n. Sorry, knocking the camera there. So I've got 5n. Of course we need to go backwards now to get the next part of it, because 5 times 2 does not give us 7 there, does it? Okay. Now we're going to go backwards, so this time I'm going to be taking away 5, so 7 take away 5 leaves me with 2, and then I need to go backwards again to the 0 term, and 2 take away 5 leaves me with -3, so we get -3. So 5 times 2 gives us 10, take away 3 is 7, and of course 5 times 5 is 25, take away 3 is 22. So that is our nth term, 5n minus 3. Then we're on to some money. We've got 3 people have amount of money. We know how much one person have. So Cal's got £420, which is 3/4 of B's, and Ali's to B's is 7 to 10. So simplest way for me to work this out, I'm going to put those in order. So we've got Ali, B and Cal, and we know that Cal has 420, so let's work out now. Now Cal's amount is 3/4 of B's amount, so we can take that 420, we can divide it by 3 to find out 1/4, and then we can times it by 4, and that will give us how much B has got. Let's clear that off. So we said 420 divided by 3, remembering to move to the side, times by 4, and we get 560. So that is how much B has got. We're nearly there, and we know that the ratio between Ali's and B's is 7 to 10. So that means for every 7 that B's got, every 7 that Ali's got, B's got 10. So we take that amount, the 560, we're going to divide it by the 10, times it by 7. So now 560 divided by 10 times by 7, and we get 392. And that is how much Ali's got, which is all they were interested in. So that is our answer, 392 on the answer line there. Okay. Question 10, we've got a Venn diagram, and all we're given, so we don't know any reference, all we know is the probability of it being B is half. Now, for the moment, I'm going to disregard what's in the middle because they align to both. So I'm going to look at the rest. So I've got 30 plus 6 to give me 36. And I'm going to take away that 20, which will leave me with 16. And that is our value for what goes in the middle. Okay. So 2 marks, but relatively simple. Now, question 11. Write down the equation of a straight line parallel to y equals 5x. Y minus 5x equals 4. Okay. Of course, we know, and I'll put it here, we know y equals mx plus c, because it applies to both questions for this one. And because it's parallel, we know that the 5x, the 5 is our gradient. So as long as we're having anything along those lines, we can work out, we could do y minus 5x equals 3. All we're doing is we're moving that line across one, aren't we? Okay, it will, because it's got the same gradient, it will remain parallel. And then here, same again, the straight line has a gradient of 3. So that means straight away I can rule out that one, and we're left with these two. And because it's got a gradient of 3, that means for every one the x goes up by, the y goes up by 3. So if it was just 3x, if we did 6 times 3, it gives us 18, which is not what we've got there. To get from 18 to 13, we'd have to take away 5, which is that there. So we can rule that one out as well. Question 12, some frequency ones. Now this, basically, keywords in all of this is estimate. Estimate the percentage decrease. When you're dealing with these, we're dealing with frequency from a midpoint. Okay. So what you're going to do each time, you can draw an extra column on. I've done it in the past, but today I'm not going to. We look at the midpoint. So midpoint between those two, I've now got 12.5, and I'm going to times that by 24. And I'm not going to test myself too much there. 12.5 times 24 gives me 300. I'm going to do that for each one now. The midpoint between those two, in fact, I'll do all the midpoints and then I'll do the calculations. So halfway between 15 and 20 is 17.5. We'll times that by 44. Halfway between 20 and 30 is 25. We'll times that by 34. And halfway between 30 and 50 is 40, which we'll times by 18. Let's do the hard yards for the calculator now. So we had 17.5 times 44 and gave me 770. Clear that one off. Then we've got 25 times 34, which gives me 850. And the last one there is 40 times, and what did we say it was? It was 18. That's my writing. Be clearer with your writing. 40 times 18, and we get 720. So these, don't forget, these amounts are only estimates. This is the total time as an estimate for all 24 people, given with the midpoint there. Okay. So we know it's a total of 120 people, so we need a total for our time. So the total for our time, as we look through, we need to add all of those up, which is what we're going to do now. So I've already got the first one still on there, so I might as well go backwards and add them up going the other way. So we've got 720 plus 850 plus 770 plus 300, and that gives me a grand total of 2,640. And because it's looking for the mean time, so we can now do that 2,640 and divide it by the 120. So that's each journey. So same again, answer divided by 120, and we get a mean of 22. And that's minutes. So what we're saying now, last year his mean average was 25, this year it's 22. So we want to estimate the percentage decrease. So we've decreased by 3 minutes. So that's 3 minutes over the original time, which was 25. And then we times that by 100. Again, let calculator do the work for us. So 3 over 25 times by 100, and we get 12. And that's a 12% decrease. Okay, so his time is reduced by 12%. Okay. That's question 12. 4 marks. I'd say it was worth 4 there. Now 13 is basically we're working with cumulative frequency. And what happens here as we go up, the cumulative frequency table, we can see here 38 to 62, we've added the 24, haven't we? Okay, so we've added 24. So then the next one, we would add 14, then we would add 8, and so on as we carry on down. Might as well fill the rest in. 4, and then we're going to do the last one. Okay, so let's do these. So we already did. Let's follow it through from the start, make sure we are absolutely right. 38 plus 24 gave us 62, which we've got there. Then I can add my 14 to give us 76. I'll add 8, which will give me 84. Now I don't really need the calculator now. Add in 4, we've got 88, and then we've got 90. So we've done our table. I realised I did the last couple off the screen, but you could follow that anyway. Okay, so there's our cumulative frequency. So now we're going to take that data and we're going to put it on our chart now. Okay, hopefully we've got just enough room there to see everything as we look at it. So on the side, cumulative frequency, which is this number, and obviously the salary. So on the 20,000 we can go up to 36. I'll use a darker colour on this one. Actually not too dark because I don't want to lose it. So we're going to go to 36. So there's my mark there. We can see that, yes. 40,000 goes up to 62. Then 60,000 I should say, goes up to 76. 80,000 is up to 84. See, we're slowing up now. Then we're on 88, and we finish on 90. Okay. Now, the last bit. We still need our line, but of course, it's not a straight line, is it? So we're going to go curved, starting at 0, and I'm going to finish at 90, because at this point we don't know anything but beyond 90, so it's not worth going past because we can't predict on that one. Okay, so now I can get rid of the table. Done with that. Because the next part, all it asks us to do is to estimate the number of employees with a salary less than 30,000. So all I have to do now is I can mark off here exactly halfway is my 30,000, and I'll draw a line up to where my graph meets that line, and then I can draw a line across. And as I look at that, I can see there cumulative frequency I'm looking at just 1 squared over 50, so that's going to be 52. Okay. Now remember, draw those lines in. It counts as you're working out on things like that. There's 2 marks available. They want to see some evidence for it. Question 14. Small plane. So we've got a mass rounded to the nearest 100 kilograms, the mass of the fuel to the nearest 5, and the mass of the passengers to the nearest kilogram. The total mass of the plane is calculated by adding them, and the maximum mass for the plane to take off safely is 1400 kilograms. So we need to work out, can it take off safely? So what we need to think about is how could it be rounded? So if we look plane first, so I'm going to put these signs in, which we're all familiar with. Basically, it's rounded to the nearest 100 kilograms. Half of that is 50. So if I take away 50, I've got 850, and I add 50, I've got 950. So the weight of the plane, if it's more than or equal to 850, it would round up to 900. And if it's less than 950, it would round down to 900. Of course, 950 would round up. That's why we're missing that sign. So that's the plane. The fuel, which we know is 210 to the nearest 5 kilograms. So half of 5 is 2.5. So take 2.5 off there, and we've got 207.5. And then we're going to add 2 onto it. So we get 212.5. 212.5. And then the people, they were rounded to the nearest kilogram. So we were just basically half a kilogram. So we knock off half. So we've got 252.5 and then 253.5. So now, because it's been rounded, these are the lowest values it could be, and these are the maximum values it could be. So I'm going to add all those up. So clear that off. We've got 950 plus 212.5. Yeah, I'm missing a number there. 212.5 plus 253.5. And that should give me grand total of 1,416 kilograms, and we can safely say that, instead of bringing that down, 1416 is greater than 1400. So can the plane definitely take off safely? No. Okay. Legally speaking, that cannot, because it's exceeded the maximum mass for the plane. Okay. So then we're on to 14B. We've got another plane, and it's travelling 840 miles in 1 hour 30 minutes at a constant speed. And we want a speed time graph to represent this. So we're dealing with our old friend, speed, distance and time. And we know the speed is equal to distance divided by time. So we're going to do 840 divided by, now 1 hour 30 minutes is an hour and a half. So 1.5. Again, calculator comes in. 840 divided by 1.5, and that gives me 560. 560 miles per hour. We can show that on a graph. So, as we do this, if I look at my grid, I'm going to start my grid at 0. Of course, if I go up in 10s, I've got 10, 20, 30, 40, 50, 60, I've run out of space. So I'm going to go up with 15s. 15, 30, 45, 60, 75, 90, and then I'm going to go up on this side, and this side I'll go up in hundreds. And I'll go up as far as that because I don't need to go any more than that. But we know at 90 we're doing 560. So I'll put a line there. And hopefully my card here is long enough to draw my line. Look at that, just. Okay. I'll draw my graph on there. Okay. And that's us done. Now, this one was a good puzzle. You've got Amy, Beck, and Becky each make integers, so whole numbers, using 3 single digits. We can use any integer, digits may be repeated, and then there's some rules. And we need to find out how many they make. Now, you could do trial and error with this, but trust me, you don't want to do it because it's going to take us so long. So let's deal with the first one. Amy, 3 digits. Okay. Then there's going to be Becky, also 3 digits. Now the rules are that Amy makes odd integers with a first digit greater than 6. Okay, now odd integers, that means there's only going to be, we do 1, 3, 5, 7, 9. Okay, so there's 5 there. So there's 5 options for the last number, because they're going to end up as odd with a first digit greater than 6. Now what people do is they think, oh, greater than 6, odd, 7 and 9, and they only go for 2, but it doesn't specify. It's the end number that has to be odd. So first digit greater than 6, we can have 7, 8 and 9, which gives us 3 there. Okay. Now there's absolutely no criteria for that last one, so that can be any of 10. So we can do 3 times 10 times 5, and that's going to give us 150. And that leads, see what I mean? If you would want to do 150 of those. The last one, Becky makes even integers with a first digit that is not 0 or 1. So evens, again, that has to be out of 5. First digit that is not 0 or 1, so that rules out 2 of them, which means we've got 8 choices for that one. And again, there's no restriction on that. So we do 8 times 10 times 5, and that's going to give me 400. So to work out how many more Becky does than Amy, I'll just do 400, take away 150, and that leaves me with 250. And that is my answer there, 250 for that. Okay. So question 16, x is a positive odd number, and it says without expanding brackets, explain why there's only one value of x for which y is negative. So if we start off, there's a positive odd number, so if we say x equals 1, then if we look at that as we go through it, so if x is 1, take away 2, we've got minus 1. Then if that's 1, take away 4, we're going to get, times that by minus 3, and 1 plus 5, we're going to get 6 there. Okay. So minus 1 times minus 3 is 3 times 6, we get 18. So we know positive. If x equals 2, so we know positive odd number, so it can't be 2. Next one would be 3. 3 take away 2 is 1. And I multiply that. Now 3 take away 4 is minus 1. And of course, we only got 3 take away. So 3 plus 5, we get 8. So 1 times negative 1 is negative 1, and negative 1 times times 8 equals negative 8. So we've got negative there. And then, again, another positive. So if we do x equals 5, this is just to stitch it up. So 5 take away 2 gives us 3. 5 take away 4 gives us 1. And 5 plus 5 is going to give us 10. So 3 times 1 is there, and then we'll get our 30 there. Okay, and again, positive. So this, x equals 3, is the only one that will give us a negative. Now, 17 is trigonometry. And not very nice either. So when we're looking at these, we deal with the opposites. So what we can say is, if we look at the opposites first. So we've got x over the sine of 31 is equal to, and we go the other direction, and we would have 6.3 over the sine of 119. So when we work that through, what we will do, so then to rearrange this, we're going to end up, let's say that x is equal to 6.3 times sin 31 over sin 119. Let's bring the calculator into play for that one. So it looks like a complicated one, so I'll put that fraction button up first. 6.3 times sin 31. I'm going to close my brackets before I move down, and I'm going to divide that by sin 119. Close the brackets, and we should have our answer there. We've got 3.70 and so on. Okay, so 3.7. We're going to have some extra numbers there, but I'm happy enough with that. It basically, they can see the right answer, and the mark scheme is going to be 3.7 and maybe some digits after it, but that would be good enough for there. Okay. Question 18. We wanted an expression for the nth term in a quadratic sequence. Now, just to give me a bit more room, what I'm going to do, I'm going to rewrite these here. So I've got the first terms, and I've got 8, 21, 40, and 65. So when I look at these now, what I've gone up by each time, if you hear any strange noises in the background, it's just the dog trying to investigate what's going on. So when we look at these, between 8 and 21, we've added 13, then we've added 19, and then we've added 25. Okay. Now, that's our first row. So let's do the second row, as we normally do here. Okay. So, this time, between 13 and 19, I've added 6, and between there and there, I've added 6. So I'm going to work with those now. Now, there's a particular thing we have, and you recognise this by now. So we can say, up here, we'd have A plus B plus C. The next line would give us 3A plus B, and the bottom line of it is 2A. Now, for this one, if we say that 2A equals 6, that means A must equal 3. So we've now got the value of that. So now the next one, if we say that 3A plus B equals 13, so 3 times A, so 3 times 3 is 9, plus, and it's what we're going to add to that to get to 13, and that's going to be 4. So B equals 4. And then on our last one, we've now got A plus B plus C. So we've now got 3 plus 4 plus something will equal 8. And 3 plus 4 give us 7, so C must be 1, so C must equal 1. And that allows us to finish off our scale then. So we've got 3n squared plus 4n, and the last bit is plus 1. So we've got the 3, the 4 and the 1 there. Okay. And that's all that done, neat and tidy. So we've now got some regions to be sorted out like this. Now the first one, I'm going to do the easiest one first. I'm going to do that one. Y is equal, greater than or equal to 2. So when we look at that, on the y-axis we've got 2 there. So I'm now going to carry on that line all the way across. Really should have done with the, could have done with the ruler for this, but hey ho. So that is y is greater than or equal to 2. The second one I'm going to work with, I might as well do this one, x plus y equals 4. So if x is 0, y must be 4. And if y is 0, then we know that the x must be 4 as well. Okay, so we can work on that one there. So x is 4, y is 0, gives us 4, and so on. And again, I'm going to draw the line through there first, and then carry that line on and up. Again, it's not the brilliant line, because I haven't brought my big ruler. And we've got x plus y equals 4. It's always nice to label them. They like to see the labels on these things, because it shows you're proving to them which one is which. Okay, and we can work with those. So now y is less than x plus 5. So I'll do this in yet another different colour. So we can look at that, and y, so if x is 0, plus 5. And if x is 1, plus 5. And then so on and so on. Okay, and that's going to give us that line there. Okay, so again, I'm going to draw as much of that down as I can and then carry it on. We've got our line there. So y is less than x plus 5. And our region, which is what we're after, we can label it as R, or we can shade it in. Generally, more often than not, they'll ask you to shade it, but they have said label it, so we can just put the R in the middle there, and that covers for what we need to do. Okay, that is the only thing that represents all three of those values. Then, question 20, we're going to be factorising. So, I know some of you like the nice big equation to do it. Me, I like to use the grid method. So 5n squared, and then I put my plus 2 there. So now I'm going to have 5n and n. And when I'm looking at plus 2, well, I mean, I'm looking at how do I get there. Now it's positive, so they're both either positive or negative, but here is positive. So I'm looking at 1 times 2, so I've just got plus 1 and plus 2. And that's my answers. 5n plus 1 and n plus 2. Now if I wanted to carry it on, I could. 5 times 2n is going to give me plus 10n, and plus 1 times n gives me, well, we can say plus n or plus 1n, but when I bring those two together, that's going to give me the plus 11n. So that proves it. Didn't need to do the bit in pink, it just adds it up for us. Okay. So, brings us on to the second part of this. We've got 5n squared plus 11n plus 2, so it's the same on there. And it says any term of the sequence, are any terms in the sequence a prime number? Okay. Now if I look at this, I'll start off with the first term. So we're going to do 5 times 1 squared, then we'll add 11 times 1, and then we'll add 2 to that one. So 5 times 1 squared is 5, 11 times 1 is 11, so 5 plus 11, 16, plus the 2, we get 18. So the first term is that. The second, we're going to do 5 times 2 squared. So 5 times 2 squared is going to give me 20. Then I'm going to add 11 times 2, which is going to be 22. And then I'm going to add 2 at the end, which of course is going to give me 44. And that's my second term. And we're going to go up quite big then, aren't we? But what it tells us is, no matter whether we're using an odd or an even, we're still going to end up with an even number. And the sequence will always be even, and it's greater than 2. So, are any of the terms in the sequence a prime number? We can say no. And we can even write that explanation down. We can say the sequence will always be even and greater than 2. Now, question 21. They've chucked some nasty things at us in this one, haven't they? But this one's good. So, volume of a sphere. So we want to know what fraction of the space inside the cylinder is filled up by the spheres. It tells us they've just fit. So if we want the volume of those 4, the spheres themselves, we have got 4 times 4/3 pi r cubed. So that's a volume of all 4 spheres. Now the volume of the cylinder is going to be pi r squared times by the length. Now, we're not given the length, but we can deal with the radius, can't we? And each cylinder, basically, we know the diameter of each ball is going to be 2r, twice the radius. So we've got 2r plus 2r plus 2r plus 2r. So we can use 8r for that one. So we want to find out what fraction of the space. So we're going to take this top one and do 4 times 4/3 pi r cubed. I'm going to divide it by pi r squared times 8r. Now, as usual, we can cancel things out. The pi and the pi, they cancel out. R cubed divided by r squared divided by r, they're going to cancel out. So we are left with, when we look at that, we're left with 4 times 4/3 over 8. And what we can do then, 4 times 4/3, that's going to give us 16 over 3 divided by 8, which we don't really want to do, divided by it and all of that. So we show it a different way, 16 over 3, and we're going to divide it by 8 over 1. So we do keep flip change. We've now got 16 over 3 times by 1 over 8. So we end up with 16 over 24, which we cancel down to 2/3. Okay, realised I did that last bit off the page. I was in the flow, and that's what we've got. So they take up 2/3 of the space. Okay, so we had it worked out there. It looks messy like that, so we change the format, keep flip change, and then cancel down to 2/3. Now, 22 is all about, it says solve. So what we do is we take this and we rearrange it, because it's going to make it easier for us to work out. So what we now say is that 3x squared plus 13x minus 10 is greater than 0. And that's the important bit now, because this is what's going to help us solve it. So initially I'm going to use my usual grid to solve these, and then I'll work on the last bit. Okay, so I've got 3x squared and I've got minus 10 there. So I'm going to put 3x and x there. So I've already got 2 of my brackets. So I've got 3x there and x there. Now for minus 10, I can do 1 times 10 or 2 times 5, but I know one of them's got to be negative, and I've got to think what's going to get me to this point. Okay, so I'm going to deal with minus 2 and a plus 5. So 3x minus 2 and x plus 5. And I'll show you this again, don't really need it, but 3x times 5 is going to give me plus 15x, and minus 2 times x is minus 2x. And of course 15x take away 2x, we're going to get our plus 13. So we're covered there. So we've got our values. But of course now, because it's greater than 0, we have to alter these. Now I'll do this one first because it's the easiest one. That means that x must equal minus 5 for this to be 0. Minus 5 plus 5 is 0. And if we look at this one, we do the opposite here. We've got our 2, but of course it's been times by 3 there, so we have to divide by 3 to show that there. So x is equal to 2/3 and x is equal to minus 5. And there's our solution. (23) is a graph which looks really, really nasty. But they only want us to come up with a couple of criticisms. And the thing is, it's a roller coaster. It starts at ground level, but here it's shown it's starting at 36. So we can say the graph should start at 0. And we can even say 0, 0, or we could say that it starts at 36, starts at the wrong height or something along those lines. Okay. And then what we can work on those is, as well, is the graph. It goes too high. The graph should not extend beyond 36. I'm just going to say go higher then. Now, we've got those just as a couple of quick ones. There's only 2 marks. Doesn't have to be fantastic, but something along those lines. And then we're into 24. Now, this is good. A, B, C and D, E, F are similar, which means that on the triangle, the angles will remain the same, but the sides are different, okay? But they're scaled different. It's the same triangle, so it's just either bigger or smaller. So what we need to do, we've got sides to compare to get a scale, but we haven't got the same sides, so we need to work out one of the other sides, don't we? So if I work with the first one, if I say the area of my triangle is half A times B times sin C, okay, I can now say that my area of 39.532 is equal to 1/2 times, and we've got, you can say 3 by B times sin 127 . So when I rearrange that, I've now got B is equal to 39.532 over sin 127. And what I can do with that now, let's show that in. 39.532 over sin 127, and that gives me an almighty big number. So I've got 49.4499. But I then need to divide that by 3. Okay, so I'm going to take that answer and divide it by 3, and it gives me 16.499 and some more numbers. So I'm going to round that. I'm just going to say 16.5 for now. So I can now work with it on the other. I've now got the scale to work with, so I've got that side as 16.5. So now I can work on my scale. I can do 16.5 divided by 4.4, which gives me 3.75. So that gives us a scale of 3.75. So I can now do 6 divided by 3.75 to give me and again got decimal, so I've got 1.6. So now I can work out my area now. So I can do 1/2 times 1.6 times 4.4 times sin 127, and let's do that all in one nice big row. So we had 1/2 times 1.6 times 4.4 times sin 127, close brackets, an answer of 2.8. Okay, and again I'll just put my 2.8 there. Sorry, I've done a bunch of stuff off the page then again. Concentrate too much on the calculator, but I'll leave that up there so you can follow where we did. I think it was only the last bit. Were you sure the 1.6 or just did for the area? It's 1/2 base times height times the sine of our angle to give us 2.8. So the answer for our missing side there is that one. So sorry, our area. Okay, all good. And of course, any questions. So hope the video's been of some use to you. See you again for the next one.